to B.1, our mathematical objective is I can recognize the relationship between complementary angles by finding the sine and cosine of those complementary angles. So we should know what complementary angles are to start. So the definition of complementary angles are two angles that add up to 90 degrees. Okay, so that's the definition of complementary angles. It's any two angles that add up to 90 degrees. They don't have to be in a triangle. They could be any two angles. However, in a right triangle, the acute angles are complementary, okay, no matter what. Why? Because a triangle adds up to 180. In a right triangle, my one angle is always 90, so the other two have to be 90 as well. It makes up the rest of the 180. So we always know that these two angles are complementary. Why do we care? Good question. Let's look at an example where we're looking at both of the angles. So here in triangle ABC, we're going to start by finding the sine of A and the cosine of A. Okay? So here's my angle A. If I label my sides, I have my hypotenuse, my opposite side, and my adjacent side. So if I'm finding the sine of A, right, sine of A equals O over H, which equals, my O is 4, and my H is 5. Then, cosine of A equals A over H, my A is 3, and my H is 5. Okay, so my sine and cosine are 4/5 and 3/5. Alright, now we want to look at angle C. So we want to be careful. Okay? I am now changing my angle. If I change my angle, my hypotenuse does stay the same, but my opposite side is now over here. My adjacent side is now over here. So again, just reiterating, when your angle changes, when your angle changes, your sides are going to switch as well. Okay? So then, the sine of C is still opposite over hypotenuse. My opposite side is now 3. And my hypotenuse is still 5. Oh, this board. Then for the cosine of C, really not doing anything, it's going crazy. For the cosine of C, cosine is adjacent over hypotenuse. My adjacent side is 4, and my hypotenuse is 5. Alright, now you should notice something about these angles. Okay? If you notice, sine of A and cosine of C are the same, and cosine of A and sine of C are the same. This leads us to what we call our complementary angle theorem. So the complementary angle theorem states kind of two different things. We're going to write this in two different ways. You have the sine of x equals the cosine of 90 minus x, right? So the sine of one is equal to the cosine of the other, of a complementary angle. Or, the other way we can say is, if sine of A equals cosine of B. Then A, okay, that should be a big A, plus B equals 90 degrees. Okay, so again, this is saying if this trig ratio is equal to that trig ratio, then I know these are complementary and they add up to 90. Okay, so that's two different ways of saying that. So looking at example 1, I'm going to write the equal trig ratios. Okay, so kind of using what we did here. If I have sine of A, you have to switch the trig ratio and switch the angle. Sine of A equals cosine of B. If I have sine of B, I just switch the trig ratio, switch the angle. Cosine of A, switch the trig ratio, switch the angle. Cosine of B, switch the trig ratio, switch the angle. Okay, so they're kind of saying the same thing, but it's good to write it all down. Okay, let's look at some of the ways we are going to use these problems on our next page. Okay, for our first one, we want to set up two different equations to solve for x. So the first one I'm going to do is, I have this 45-degree angle, and I'm going to label my sides. Okay. Then I'm going to set up an equation that uses the three things I have. It uses my angle, and uses the adjacent side and the hypotenuse side. So I don't really care about the opposite side. So if you think about then what uses H and A? Cosine uses H and A. So cosine of 47 degrees equals my A is x and my H is 44. Eventually we're going to look into solving these types of equations, but we're going to do that later. Right now we're just looking at setting up the equations. Okay? So again, I don't know why I put 47, 45. Sorry about that. The cosine of this angle, can't read, is A over H. That's all we're saying. Now, one thing to remember, the cosine, so sine of x equals the cosine of 90 minus x. This is true the other way as well. Okay, I could have written it either way. So now if I want to rewrite, I want to write a different equation, I'm going to say the same thing. Right? The sine of 90 minus 45 equals x over 44. And I'm actually going to subtract those. The sine of 45 degrees equals x over 44. So those are my two equations I can write. These angles won't always be the same. It's just because 90 minus 45 is still 45. For this next one, I'm going to set up two equations to solve for x, and I'm going to set up two equations to solve for y. Okay, so starting with x. Here's my angle. So I have my hypotenuse, my opposite, and my adjacent side. Again, I'm not going to worry about y right now, so we're using a and h, so therefore we're using cosine. So cosine of 50 degrees equals x over 12. That is my first equation. And just like we did in the last one, I can then say the sine of 90 minus 50 equals x over 12, which is the sine of 30 degrees. No, 40 degrees. Sorry guys, I can't do math today. 40 degrees equals x over 12. Now if I want to do it for y, same hypotenuse, same sides, but now I don't care about x, right? So if I'm setting up an equation for y, I'm using sine. So sine of 50 degrees equals opposite over hypotenuse, y over 12. Easy. That's my first equation. My second equation, again, I have to switch my ratio, or my trig ratio, and then 90 minus 50. So cosine of 40 degrees okay, so again, I'm switching my trig ratio and I'm switching my angle. You just have to do 90 minus that angle to find the other angle. All right, let's look at our last set of problems that we're going to do with this. Okay, for this one, we're going to use our other part of what our complementary angle theorem says, or the other way of writing it, right? If sine A equals cosine B, then A plus B equals 90. Okay? So basically in here, I know that this angle and this angle are complementary. So therefore, theta plus 25 has to equal 90 degrees. Thus, I'm just solving for theta. 90 minus 25 is 65 degrees. Nice and easy. Same thing here. Here are my two angles. 80 plus theta equals 90. I'm going to subtract 80 from both sides. Theta equals 10 degrees. Last two. I have sine of theta equals cosine of theta plus 10. Here's my angle. Here's my angle. Theta plus 10 equals 90. This one's a little different. I have to simplify first. Theta plus theta is 2 theta. So 2 theta plus 10 equals 90. Now I'm solving. Always deal with addition and subtraction first. Then multiplication or division. Theta equals 40. Same thing here. Again, I have 2 theta minus 45. Right, I'm just combining these two. So addition and subtraction first. 2 theta divided by 2 equals 135 half degrees, or 67.5 degrees. And that is it. So go ahead and there is that one extra problem that we did not do. So if you'd like to look at that one, it's using Pythagorean's theorem to see what we are doing. Otherwise, I'll see you guys tomorrow in class.